Okay, number 16. Let's see, what's the domain, right? So the domain means what can x be in this function, in the log function, and not break the function, right? Well, you can't raise 10. That there's no base down here, but it means a 10, right? That's a common log. And so what can you raise 10 to get 3x minus 2? I mean, let's just write that down for a second. What can we raise 10 to get 3x minus 2? Well, I don't know. Whatever you're going to raise 10 to, it's going to be a positive number. This is going to be positive. You can't raise 10 to an exponent and get a negative over here. It just can't happen. So we want 3x minus 2 to be greater than 0. That means 3x minus 2 has to be positive. So I move the 2 to the other side by addition, right? And then I divide by 3, and I end up with x has to be greater than 2/3. That's how you do these problems. You say what you're taking the logarithm of has to be a positive, and then you try to solve that inequality. All right, number 26. We're either going to have one that you combine all the logarithms together into one logarithm, or we're going to have one that makes you exercise the opposite of that property, where you're separating logarithms, right? So I'm going to try to join these three logarithms together. I'm going to work from left to right, but I don't really think it matters what order you go in. So the addition means we got to multiply these two expressions together. So I'm taking x minus 1 over x times x over x plus 1. And you can see these x's here are going to divide out to 1, and we're left with x minus 1 over x plus 1. So now I'm down to natural log of x minus 1 over x plus 1. And then I've got still minus the natural log of x squared minus 1. Well, minus means we're going to divide by this stuff right here. So if I take x minus 1 divided by x plus 1, and I divide it all by x squared minus 1, well, I've got a fraction divided by something. So I convert that to a fraction multiplied by something. So I multiply by 1 over the thing I'm dividing by. So what really happens is what I'm dividing by ends up in the denominator. See, this x squared minus 1 ends up in the denominator with the x plus 1. So I'm down to natural log of x minus 1 all over x plus 1 times x squared minus 1. And I do see some simplifying that would go on here. X squared minus 1 is the same as, let me write this down here first. It's the same as x plus 1 times x minus 1. So I got x plus 1 times x minus 1. And I see this x minus 1 is going to divide out with that x minus 1. And I've got x plus 1 squared. So we're probably going to see in the back of the book x plus 1 squared. And then we probably want to make note that we've simplified our expression down. X cannot be equal to 0 because you can't divide by 0 here, right? X cannot be equal to negative 1. And we might be able to do this a little bit more efficiently because all of these need to be positives. Like that needs to be a positive, that needs to be a positive, that all needs to be a positive, right? So if they ask us for the domain, we'd have to do some more consideration on what would make all of these guys positive, right? So as I just kind of scan it, it looks like if x is bigger than 1, right? Because if x was bigger than 1, it's going to make this guy over here positive. This would definitely be positive, and this would be positive. So I think we could probably just say x needs to be bigger than 1, and that takes care of this stuff, because if it's bigger than 1, it can't be 0, it can't be negative 1. So this is probably our domain if they ask for that, on the test, right? So just be careful on these kind of problems. Try to understand exactly what's going on. Number 30, okay, we're going to do, 5 parts of number 30. And it says, find the domain of the f function. Well, x needs to be bigger than 3 because what am I talking about? X can be anything. It's an exponential function. Man, I was in my logarithm mode there, right? So you can raise 2 to any number. So x is an element of all real numbers. You could just say all real numbers right there. B, sorry about that. Woo, graph it. Okay, well, an exponential function looks like that, right? But this exponential function has been shifted 3 to the right. So our normal point at 0, 1 has now been shifted 3 to the right. So let me put that down. That's going to be right there, 3 comma 1. And then our exponential function is going to look something like that. Okay. B, or that's B. C, from the graph, determine the range and any asymptote of f. Well, the x-axis is an asymptote. So y equals 0 is a horizontal asymptote. And let's see, what else do we know? The range is all values greater than 0. So range is y greater than 0. Find the inverse of the function. Okay, so we have y equals 2 to the x minus 3. Here's the inverse. X equals 2 to the y minus 3. Okay, so this is my part D right out here. This is my part C right over here. So I have the inverse. Now I just need to solve it for y, right? So I'm going to go log base 2 of x is equal to y minus 3. I converted from exponential form into log form. The base is 2, the exponent is y minus 3, and I'm going to get x. That's saying the same thing right there. I just need to move the 3 to the other side, and I've got the inverse. Okay, so my inverse comes out to be y equals log base 2 of x plus 3. E says find the domain and the range of f inverse. Okay, that's a bit trickier of a question. I want x to be greater than negative 3 for my domain. So domain, because I can't have a negative. So x has to be greater than negative 3. That'll make this positive right in here, right? And then my range, okay, so let's see, the range is the y is going to be, let's see, all real numbers, right? So my y should be all real numbers, okay? Now, does that relate to this one up here? It should, right? The domain, see how this was my domain, right? Now that's my range. And then the range doesn't seem to be the same as this guy right over here. So that's because we have a little bit of a shift in, remember how we shifted this guy over 3? Well, that shifts our function, our inverse function. It shifts it back 3 based on the reflection, all that kind of stuff. So it's a little dangerous to make those conclusions from just straight out from this, okay? We'll go over that some more in class. I hope I made that clear. Thank you for watching my video.